So the name of this lesson is Angles of Elevation and Depression, which is what we're finally getting into on this third notes video. So angles of elevation, angle of depression. Now it's possible to not be either of these things. So we got to figure out which one it is. When you hear the word elevation, you should think up. It's a directional word. When you hear depression, yes, there's emotional things attached and mental health things attached, but if you're thinking a direction, you would think down. Keep those thoughts in mind, because if an angle of depression does open upward. Angle of elevation does open upward. An angle of depression does open downward. But you can't go down if you don't have somewhere to start from. You can't go up if you're not starting from somewhere. So that starting has to be a horizontal line. So angles have two sides. If it's going to be an angle of elevation or an angle of depression, one of those sides will be horizontal. If it's an angle of elevation, the other side will be up from that angle. So it'll look something like this. If it's an angle of depression, the other side will be down from that horizontal side. So it'll look something like this. But you'll notice both of those angles have a horizontal side. Angles that are neither angle of elevation or depression could be something like this, or something that has a vertical side and then opens up from there. Or if it doesn't have something horizontal, then it's in the neither category. So if you look at this picture, angle 1 is made up of two sides. So here's the arc marking it, but we have one side here and we have one side here. So the first question you need to ask yourself is, those sides that I just traced, is either one of them horizontal? And you should say yes. If the person at point B looks straight forward horizontally, they're going to see the birds. But they're not looking horizontally. Theoretically, they're looking up at the airplane. That is an angle of elevation then. So my first one to classify this, angle 1, is an angle of elevation. So let's classify angle 2. So I'm going to again trace the sides of angle 2. Here's one side looking down toward the car. Here's one side looking straight over at the birds. Is either side horizontal? Since we said yes, then my answer is either going to be elevation or depression. So then we need to ask yourself, from that horizontal, did we open upward or downward? That is a downward direction, which means that's an angle of depression. Angle 3, it's kind of weird because the car is kind of in the way, but we have a side here and then a side here to create this angle. Is either side horizontal? Yep, the car could just keep going horizontally toward the building, but instead the driver is looking up at the person, and I'm kind of giving it away by saying the word up. That's an angle of elevation. Angle 4, if I trace those sides, one of those sides is horizontal, but from the horizontal line, this goes downward. So angle 4 would have to be an angle of depression. Angle 5, if I trace those, got the side, the plane's looking down. Theoretically, planes don't look at things, but whatever. However, don't just say depression because you think, oh, hey, look, this is a downward angle. Is either side horizontal? No. Since neither side is horizontal, that's just a random angle. It's neither an angle of elevation nor an angle of depression. Now, the convenient thing is, I'll show you how when you draw these pictures, there's not really a wrong way that you could do this theoretically, because this angle of depression here at angle 4 is the same as the angle of elevation at angle 1. So pretend that, sorry, my hand hit something. Pretend that angle 4 was a 50-degree angle. That means angle 1 is also a 50-degree angle. And it's because of something in geometry that you either have learned or will someday learn. It's called alternate interior angles, where they happen to be congruent when you have parallel lines, blah, blah, blah. Doesn't really matter. It means they're equal. So, for example, if angle 2 is, remember, it was an angle of depression from the horizontal line it went down. If it happened to be a 43-degree angle, then this angle of elevation here would also be 43 degrees. Which means when I go to draw these pictures, some students don't like drawing the angle of depression because it's just not in a triangle. We're going to remind ourselves that they're always going to be congruent here. So let's actually draw one. We get a word problem. You stand 53 feet from a wind turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. We're going to draw a picture of the situation and then find approximately how tall the turbine from the ground to its hub is. So, you don't have to draw anything except triangles. But if it helps you to picture it, then yeah, pretend like you're trying to draw a very poorly drawn wind turbine. Kind of looks like a big flower. But whatever, I'm picturing that this is one of those, got renewable air going here. And you're not standing right here next to it. You are 53 feet from it. So I'm going to draw my ground. To the best of my knowledge, you cannot fly. So I'm going to draw you on the ground. So this is you. And if you look straight ahead, you're not going to see the hub. You're not going to see that point in the middle that makes it spin. You have to look up to see it, which is why this is going to be an angle of elevation. So you could go horizontally, but instead you look up at this turbine. The angle at which you are looking up is 56.5 degrees. So you notice I'm labeling it from the horizontal line up. We do have a right triangle because I have something going straight up in the air and I have the ground, and we get to assume the ground is horizontal. And the thing that I'm trying to find is the height. Height will always be something vertical. So when it says how tall is it, I'm going to put an X here. Now we're going to solve this. So yes, it's a right triangle. Yes, I have a hypotenuse. I'm not going to use it. There's nothing on the hypotenuse. Nobody cares about it. But I do have the opposite leg labeled. Remember, if my angle is here, that's on the other side of the triangle. I have my adjacent leg labeled. It's right next to that angle. And I already said that I'm throwing out the hypotenuse. So we're going to write a tangent ratio. So tangent of my angle is equal to the opposite leg over the adjacent leg. Now that you have it written, you should ask yourself, well, how do we solve that? Should I do inverse or should I cross multiply? And since it's a side length, you should cross multiply. X times 1 puts X on one side of the equal sign. 53 times the tangent of 56.5 is 53 times the tangent of 56.5. That's what I'm going to put in my calculator. Which gives me, give me a second to type it in. I got 80.07. So I'm going to just say 80.1 feet. This one didn't give rounding directions, but I'm going to go ahead and do to the nearest tenth. So not really entirely different from the review section where we went through this stuff from last week, but I had to draw a triangle first. Now clearly my drawing skills here are not spectacular. The important thing is, did I draw a right triangle and did I label it?